And we're off on a Monday night or Tuesday morning, depending on when you're watching this. If you are at Canandaigua Academy and it is 2013, if you're watching this 20 years in the future, I don't even know if they'll still have Tuesday. But anyway, on today's show, this is a biggie. Not a biggie because it's hard, a biggie because we use it all the time. We take the thing that I beat my students for using, the law of looks like, and we codify it as an appropriate way to examine whether or not series converge or diverge. How crazy is that? That's the thing. It's called the Limit Comparison Test. It is way more useful than the direct comparison test that we did a few days ago. Everywhere you can use direct comparison, you can use limit comparison. So if you were like, blah, with direct comparison, you are fine today. The Limit Comparison Test looks like this. If you can get this down, so much clears up for you. I promise. I promise you, so much clears up. Suppose that you have two series, and they're series with positive terms, because we don't get into negative terms really until tomorrow. If the limit as n approaches infinity of one term over the other is some number L, that is to say I don't get infinity, and L is not 0, then either both series converge or both diverge. We should pause. Talk about what we're doing here. This series will always be the known one. This series will be the one where we say, I know what that does. I know that it converges because it's a P series with P greater than 1. Or I know that it converges because it's a geometric series and R has an absolute value of less than 1. That series will always be the one we know about. This one will always be the one in the problem that we don't know about. Here's the thing. We pick the blue series on purpose because we want to show that the a sub n function and the b sub n function, if you were with us through Unit 7, we want to show that the two functions grow at the same rate. And if two functions grow at the same rate, and I add up their function values, so to speak, then one can't blow up without the other one blowing up. The two functions grow at the same rate, so the series have to grow at the same rate. So this takes the law of looks like and codifies it. That is to say, if I know what this one does, and I can prove that this one looks like it, and this is how we prove that it looks like it, then I'm good to go. I'm good to go. So here we go. Time to play everybody's favorite game. Does it converge? Does it converge? And we've got 3 contestants on our show. The sum of 3n plus 4 over n squared plus n plus 4. We've got 4 over 2 to the n plus 5. And we've got 4n minus 2 over n cubed minus n plus 623. 3 contestants on our show. Each time the question will be, does it converge? The answer in the first case is that we're going to make a comparison with some series we know. How do we pick the series we know? Well, we eliminate everything but the highest power of x in numerator and denominator. We just eliminate it completely because as n gets large, those terms become irrelevant. 3n over n squared, that's this. 3n over n squared, that's this. What do you know about that series from yesterday's lesson? Oh, wait, that's a p series. P is less than or equal to 1. This thing diverges. It's actually a multiple of the harmonic series. 1 over n is the harmonic series. You should know about the harmonic series. Sure enough, because of how we picked the series, this limit, 1 divided by the other, is 1. And since the limit of the quotient is 1 and the series we know about diverges, our series in question diverges. Second, I ignore everything but the most powerful term in numerator or denominator. I get this. What kind of sequence is that? That is geometric. 2 plus 1 plus a half plus a fourth plus an eighth. It is geometric with r equal to 1/2. Guess what? That converges because it is geometric with r less than or equal, with the absolute value of r less than 1. Because of how we picked the series, of course, 1 divided by the other is going to be 1. We will usually choose the b sub n series so that we get 1. This is not rocket science. We want to rig the result. And so, converges. Third, what am I going to compare with? Eliminate highest power, eliminate everything but highest power, numerator and denominator. Simplify. Good. 4n over n cubed is 4 over n squared. So here we go. I know that the limit, because of how we picked the series, I know that this limit is going to be 1. The question is, what does that 1 do? Oh, wait, that's a p series. P is greater than 1. This will converge. So our series converges. That's the way the game is played, folks. The law of looks like actually works. It actually works. For you to consider. We will consider them full group when we get back together manana. I want to know if this one converges or diverges. And I want to know if this one converges or diverges. Couple of things for you to consider between now and the time we see each other again. Go get them, folks.